All right, Donnie and Andrew, go at each other. Go. Everyone's mute.
So, Donny SFT.
Andrew, my arch nemesis.
um, I guess, are you gonna ever come out with that review of the other review of by Dr. Dan?
A review of the review of the review? Well, yeah. I'm working on a I guess a mini book. I've already got the cover and a lot of it done.
So it's gonna be a written response kind of thing.
Well, I'll do a video series response too, but I feel I'm also updating my special creation book. So I feel, and I understand you'll disagree, but I guess we can get into this. Yeah. I feel like Dan dodged 99% of the book. So the one argument that I think is worthwhile in giving an extensive response to is his rebuttal to my explanation to the nested hierarchical patterns that we see in terms of the distribution of the mutations found within the ERV sequences.
Sure.
But his response to the function of the ERV sequences I felt was weak, and I think he kind of dodged. So I'm curious as to your thoughts then, Andrew, because in the book, I'm not sure if you have a copy of it, but in the book,
no, unfortunately, by the way, but that's okay.
In the book, I go over countless examples, dozens of papers, a lot of papers from 2022 that dig into the numerous functional roles of the ERV sequences. And John knew it was coming. Let me just show you one, and then I wouldn't mind your response to it.
Sure.
And then, of course, you can ask me anything as well. So, John, you knew it was coming. You're enjoying your fruit tray. There we go. Look at him. One click away. John was ready.
Full screen. Full screen. Full screen.
See, John, you're the only one I'll never mess with. Okay, here. So here's just one out of 100 I could show you, but I like this one specifically, especially for just your lay person that may or may not be familiar with endogenous retroviruses as evidence for common descent. I find this excerpt rather interesting. Okay, so here we see HERVs, human-specific ones, appear to play important roles in physiology, fetal development, and human evolution. If the accidental, so here's what I want to touch on and emphasize. If the accidental infection of a mammalian ancestor by an exogenous retrovirus, and for context, evolutionists believe that endogenous retroviruses are essentially the ancient remnants or relics of past exogenous retroviral infections.
And we can get into that for sure later.
Yeah, definitely. By an exogenous retrovirus had never occurred. The placenta, and don't worry, if we only got limited time here, Andrew, I know you and I were working on setting up like a podcast discussion where we can go.
No, however long you want to go, I'm willing to go.
So the placenta and the mammals that produce it, including humans, notice this, would have never existed. And, you know, I'm a human, I'm a mammal.
Yeah.
Okay. I like to exist. I think you like to exist. So the creationist explanation is basically an answer to the question that I frequently ask. Are these really the ancient remnants of past viral infections, or are these created units of DNA function? Well, we know that without certain classes of these retrotransposons, we couldn't exist because they play incredibly important roles in placental and embryological development. So to me, that suggests design. So if we share certain of these with, let's say, the chimpanzee, well, the chimpanzee needs functional DNA elements to assist in embryological development as well. So we would expect to share. As a matter of fact, I pointed in the book, I wouldn't be surprised if all life, right, for the most part, shared endogenous retroviral-like sequences. Go ahead. What are your thoughts on this specific paper? And do you have any empirical evidence for the co-option or even just the evolution of these types of novel functions? Andrew, go ahead.
Yeah, so I guess a few things come in mind here. Which one to start with, because I know that might lead us to a tangent. To answer your question, basically, the reason I think these different functions have been co-opted is we never find, for example, a complete functional ERV, in the sense that, well, if most of the time, if you do have a functional ERV sequence in its entirety, you get a retrovirus. Like we've seen that you activate it with certain mutations and out pops a retrovirus, basically, and no one wants that because it obviously causes lots of disease. In fact, we see certain ERVs actually do cause diseases, many diseases in humans and other animals. But the reason I think these functions have been co-opted, basically, is, like I said, because we don't find complete functional ERV sequences. Instead, we find the ENV gene, for example, has been used for this particular function, or the POL gene for reverse transcriptase has been co-opted for a different function. But what would be surprising to me, at least, or at least to my limited understanding, would be if we found these different genes interacting with each other in a self-organized way, in this kind of what would be a good way of just kind of like a intricate pattern. I don't think I'm explaining this well, but yeah, that's my initial thought so far. Go ahead.
Well, I appreciate that. And just based on your comments here, we could have a 2-hour discussion. But,
Yeah.
Dan pointed this out too. But in my book, I specifically address this argument that claims, well, it's not a full endogenous retroviral-like element that's functional. It's just parts, right? Again, for context, your endogenous retrovirus is made of your LTRs, long terminal repeats on both ends, GAG, POL, ENV properties of it, right? And as you pointed out, the evolutionist response is, well, it's just certain aspects of the ERV that's functional, which it's wrong. Because it would be like saying, well, it's not the human being as a unit that's functional. It's just certain aspects of it, right? The heart, the liver, the kidneys. No, the properties of the endogenous retrovirus, they do function in different ways, because many of the functions include determining cell types, embryological development, as I pointed out earlier. They act as antiviral protectors, gene regulation, so on and so forth. They even act in tumor suppression. So some of their functions, yes, it's a certain aspect of it, right? Let's say the ENV or the POL gene that help with a specific role, let's say embryological development. But there's other functions where it's their properties in their entirety that allows them to perform their functional roles. Here's a fascinating paper I like to point out. Switching Sides, How Endogenous Retroviruses Protect Us from Viral Infections, from 2022. It's not just, one or two aspects or elements of the ERV unit that help with this functional role. No, it's the entire unit itself. It's their similarities, the POL, the GAG, the ENV, the LTRs, everything about them is necessary. The way they're built, the way they're structured is necessary to perform their roles in fighting off exogenous retroviral infections. Okay,
So just to clarify for a sec, are you suggesting that the designer intentionally put these gene sequences together because they had to be together to perform their specific function?
Well, notice
that doesn't make much sense to me.
No, it makes sense, because a good designer has to build systems with antiviral protectors. For example, our computers have antivirus programs, Norton antivirus, for example. And right here, if you see, ERVs have turned out to represent important components of the antiviral immune system, not only regulate cellular immune activation, but may even directly target invading viral pathogens. So this is fascinating design, amazing design, that if we are bombarded,
right, I understand that. I understand you're
I'm
talking about
almost,
the
I just
viral
want to get, I just
function.
want to get to the key part of this. The point I'm trying to make is, if let's say a Russian spy, right, were to infiltrate the United States government, well, he's going to have to, he can't come in and obviously be like a Russian soldier or something, right? He has to come in and he has to look the part. Well, it turns out that the functional role of the ERVs are predicated on their similarities to exogenous retroviruses. So they have to have those similarities, the GAG, the POL, the ENV, the LTRs, in order to perform one of their many functional roles, which is viral mimicry and tumor suppression, same thing. So yeah, everything about the ERV is functional. And the same thing goes with the reverse transcriptase, the integrase, in terms of the fact that they can jump around, turning genes on and off. And a lot of the variation generated is passed on to the next generation. So all of these things, it's not just one or two parts that are functional. It's just wrong when the evolutionists point that out. Everything about the ERV is necessary to perform these roles. Andrew, go ahead, take your time.
Hey, Donnie, can I ask a question too?
Yeah, sure, brother.
I was going to ask, do you try to touch on what's called the polymorphism code functions with ERVs and DNA? Are you familiar with that word?
Yeah, are you talking about like a polymorphism, like a variation, or like a single nucleotide?
Well, yeah, it's another classic example we were talking about earlier tonight, where we can't understand God's technology, God's code, until we learn how to do it on our own. So polymorphism, it's a human term for what we do with our own code, like you were actually talking about, like with our own software today, where we literally use identical code from one function or class structure to another, with either a slight variation or just a instantiation, as it's called, of a new object, to do something similar, but in a different way, and oftentimes in a different part of a program, or even an entirely different program, exactly as ERVs do.
Right.
ERVs are a classic example of what's called polymorphism in software design.
Well,
Hey,
a world without, actually, no, before I say anything else, Andrew, I want to be respectful. Go ahead, because I know there's some things you probably want to respond to there.
Yeah, so I understand what you're saying here, that each of these elements can itself have a function. But I don't think you really addressed my point that, or say, for example, you can have the ENV gene and the POL gene. Each can have its respective function for different organisms, but you don't necessarily find a complete sequence with the POL, the GAG, POL, and ENV gene all concentrated together and performing an integrated function.
Andrew, I just showed you that, yes, every single I'm sorry, but like, if you're gonna use Dr. Dan's arguments, then you're just gonna be shown to be wrong, because Dan's wrong. I just showed you that one of their functions in fighting off exogenous retroviruses and viral mimicry, if they didn't have the specific properties that make them up, like you're pointing out, the LTRs, the POL, the GAG, the ENV, then they couldn't perform that role. Everything about the structure of the ERV allows them to fight off viruses.
Okay, so to clarify, you are saying the GAG, POL, and ENV have to be together in order to perform this kind of viral repellent function. Is that what you're saying?
The viral mimicry function is dependent on their sequence similarity to exogenous retroviruses. Exogenous retroviruses are also made of what? LTRs, GAG, POL, ENV. The ERV also has to look like that in order to perform their job. For one, acting in tumor suppression, as we can see here, notice it actually teams up with ERVs, ERVs, to activate the immune system causing the immune system to attack villainous tumor cells that
Full
are
screen.
disguised as ordinary cells. So they have to look like the exogenous retroviruses in order to perform those roles. So yeah, what they're
Full screen.
the way they're structured, okay, is necessary to perform their roles. That means, yes, everything about the ERV is functional and necessary and important. Go ahead.
Donnie, if I may further help strengthen that argument, again, in modern human software engineering, to be able to recognize, much less to adapt or quarantine a virus on a computer, you have your antivirus software has to have the same code as the virus to be able to identify, to be able to do the comparisons with it, much less to do certain things. Some viruses, or even like rootkits, for example, are so hideous. So so whatever you have to literally mimic parts of the viral code to be able to combat it. So you're describing literal software.
Exactly. Actually, you just said it perfectly.
Yeah, that's how vaccines work.
These antiviral programs that Brother Joel's pointing out here need to be built, need to have those similarities in code to that which they're attacking and stopping in order to do the mimicry mechanism. And just right here in this slide right here, this requirement explains why a creator, because here's one of the main arguments, speed of sound, Dan, Andrew, and it's a great question. It's a fantastic question. Why did God create functional units of DNA that resemble viral-like sequences? Well, this is the answer. And it just looks like Dan's rebuttal to my book was, well, I don't like the answer. You just shrug it off. It makes you wonder, is he really looking for an answer? So this requirement explains why a creator would introduce genetic elements into the human genome that share sequence elements with viruses. It's necessary. It's good design. And as Joel's pointing out, this is also what we see in man-made design, in coding, in computer systems. I typically look at modes of transportation. Go ahead, Andrew. Take your time.
So I'm sure you're of course familiar with the certain regions of the genome where instead of these complete ERV sequences, the genes themselves have been removed, and you have LTRs on one side, or more, I guess more commonly, a single LTR. So for that, you would have to prescribe different functions, would you not?
Well, yeah, and I have a whole section on that in my book too, right here, actually. You mentioned it right as we were on the slide. So most of the so-called shared sequences, right, because it's not just like 100, it's thousands, but we're not looking at full ERV sequences. And what I mean by full is you have the host genome, and then bam, right there, you got the LTRs, the GAG-POL, the ENV. What we see is a lot of solo LTRs. Notice this slide. If you read that carefully, 90% of ERV sequences don't even resemble full. This is what you're talking about, Andrew. It's a good point. Or true endogenous retrovirus, because they lack standard ERV genes, GAG, POL, ENV, and simply represent, notice this, simply represent long terminal repeats, which can serve as binding sites for initiating or enhancing gene expression. So in other words, what we're looking at here has nothing to do with the ancient remnant of a viral infection. No, we're just looking at functional stretches of DNA that function in many ways right here, gene expression. So yeah, that's a good point. But yeah, we expect function, and then that's what we find. Go ahead.
And Donnie, if I may as well, again, real quick, you seem like you know about jumping genes as well. You're referring to LTRs and line 1 retrotransposons I heard you mention earlier. The jumping gene phenomenon, I think, further confirms what you're talking about, and I can help expand if you.
Yeah, go ahead. Yeah, like for example, right here is a paper. ERVs or retrotransposons, they can jump through they can spread through a copy and paste mechanism. Yeah, they could literally move around the genome.
Right. It's not something that happens during mitosis or gender expression, or not gender, sorry, sexual transformations, whatever. It happens in all, constantly in real time in a single organism. All of our cells right now, all of our genes are constantly, like we used to think that it was a problem. We thought that jumping genes was causing diseases, and it was literally, the DNA actively self-destructing or whatever. It turned out to be the exact opposite, especially line 1 retrotransposons. I try to talk to people about, that do AI code type stuff. how line ones, they're literal, they're almost identical, if not identical, to a lot of the code that we try to do for human code development for AI technology. It's literal AI written in the DNA code, not figuratively, literal, that are purposefully. Yeah. See, thank you. My understanding, and please let me know if I'm misunderstanding this. These things happen. These jumping genes, these retrotransposons, happen on purpose. They're parts of the code are literally copy and pasted, like you said, with direction, with purpose, with reason, with pre-engineered branching structures, basically, as we talk about in basic code. And if it wasn't pre-programmed to do it that way, then life probably wouldn't exist. We'd be all big, giant, disgusting mutant, creatures from the lagoon or whatever. But it's not. We're very, we're falling apart. The design probably, I mean, whatever. The point is that there is so much just obvious, miraculously functioning code in seemingly random processes that we're only barely beginning to understand because of our own literal human software. And I guess talking about ERVs and the suppositions, the assumptions that they were transferred from external organisms of viruses that changed our code today. Jumping genes is an even greater example of how this is all done on purpose, right?
Right. They don't just jump around randomly. They actually have preferred integration sites. And this goes back to, and then Andrew, I want to give you as much time as you need to respond right here in my slides. These are papers from like Nature. These are secular sources that are pointing out, notice, the ability of transposons to increase genetic diversity. Oftentimes as creationists, we'll call these, because here's the thing, the ERV sequence did not call itself endogenous retrovirus. The ERV sequence was named that by scientists who believe that they really are the ancient remnants of past viral infections. I prefer calling them either created units of DNA function or variation-inducing genetic elements, although they do a lot more than just generate variation, but that's one of their functions. So right here, together with the ability of the genome to inhibit most T activity, result in a balance that makes transposable elements an important part of evolution. And of course, this important part of evolution is the presupposition there. And gene regulation in what? All organisms that carry these sequences. Why do all organisms share these types of sequences? Well, if they're utilized by the organism for gene regulation, gene expression, determining cell types, embryological development, so on and so forth. But the last thing I want to say, Andrew, and hand it over to you, their ability to actually move to certain parts of the genome. Okay, like maybe you've got this gene here and another gene, and right in between, gene A would allow it to turn on a specific gene or something. It's like it's programmed to just non-randomly insert itself there in order to do a job. Its ability to do this is also predicated on the properties and structure of the transposons or the ERV sequences. So again, when the evolutionists like Dan ask, well, why do they resemble so closely exogenous retroviral-like material? It's like, again, the evolutionists are missing the point. The way they're structured is necessary to carry out their many, many roles. Go ahead, Andrew.
Well, even if they do carry a specific function, I don't understand how that explains why they share particular locations in the genome.
Because they were created that way. Holy damn.
Well, again, that's the polymorphic.
Well, I haven't
code
finished
design.
my point yet.
Yeah. Go ahead.
Well, because you can have specific DNA elements that perform a specific function. You can switch them around the genome, move them to another chromosome, if you will. We actually see this with different genes, for example, with hemoglobin, and they'll still perform the same exact function. Their location in the genome does not dictate their function. So even if these elements do contain a specific, maybe necessary function, that still doesn't explain why the designer would put them in these homologous locations in the genome, accounting for need, of course.
Yeah, thank you. And I'd love to address that again. So again, even in I want to say classic human software engineering design, it's called polymorphism. It's used in biology terms now as well, but it originated in information science. It's the idea that you can basically parent class type structures, as we also call it, or object-oriented programming, where you can create one section of code or a class and create what's called child classes to it, which have either the same or slightly different variables or methods inside of it, sequences, I guess is what we would describe it as in a biological term. And it can also borrow from and still use the near identical, if not identical, sequences in the parent class. It's called. It's a form of transference, and we see that what you're describing is exactly what we're seeing in DNA. So you're seeing the reason. The reason is because that's how God designed the code, is through these polymorphic design algorithms. The things that we use for modern human software engineering, exactly the same, for the same exact reasons. It's basically so you don't have to, copy the same code over and over and over and over and over. It's already, in certain sections and in certain ways to be accessed, and the compiler does just really cool things to make it so that it makes the human side of it, the software engineer's job, a lot easier. And then whenever it gets compiled, just like in DNA, it does a lot of repetitious things, a lot of things that you see in other parts of the sequence, like ERVs. It makes it easier.
Well, here's the
easier
question I
for me
want
in
to
this
ask.
case because the cells themselves are replicating.
But
That's
again,
what I'm saying.
I have to jump in here because
for the compiler.
I just want to say this, because this is what the evolutionist does. Okay, we point out that if we can demonstrate that these units of DNA, okay, or these stretches of DNA are functional, then the reason why we share them with other creatures, let's say humans and chimpanzees, is due to common design. They're not junk. They're not useless. They're not reflective of common descent, evolutionary.
I didn't say it was just because we shared them.
No, but wait a minute. But Andrew, again, you're dodging the way everybody else dodges in the evolutionary camp. Explain. You can't just hand wave away these functional roles we're talking about. Again, if we did not have them, from your own secular literature, they admit we would not exist. And all you said as a response, and that's okay, because it's typically all Dan says as well, and he's got a PhD in virology, right? Because there's no good answer. When you read through these papers, all you get is, well, engines of evolution, co-option, maybe this, maybe that. Well, I think they're functional because of this. Let's see empirical evidence. Show me one technical paper. I've been asking for this for the last 3 years.
Well, we're going back to the function point, but you haven't addressed the original point I made.
Andrew, please.
How did these ERV sequences evolve these abilities?
Andrew,
you're switching up the topic again. Address the original point I made.
The original
if I can also reiterate,
why do we share them with other creatures? And we already explained.
Again, I said it's not just the mere fact that we share them with other creatures.
But here's the thing. I understand you want to go to the nested hierarchical distribution of them. They're functional, and they're fun. But here's the thing, Andrew. Their functions you can't explain. Their functions are pretty many of them irreducibly complex.
Irrelevant
to the argument for common ancestry.
So they're functional roles that cannot be accounted for by evolutionary processes. Is irrelevant.
Who said they can't be accounted for?
This is a dodge.
You can't answer, dude. Just say you can't answer.
Just hand waves away.
You haven't answered my question.
Andrew, I just want you to take as long as you want. What's your best technical paper that can convince us that these many functional roles that we went over the last 30 minutes, how can these evolve?
If I may, real quick, again, reiterate for everybody, not just Andrew, we can learn how to code. OOP design is not rocket science. It's common. I mean, high school kids learn it. If we can all just put aside the common talking points, learn to code. Andrew, everybody, learn how to do polymorphic code design. It's not hard. Once you learn how to do these things on your own, then it makes sense. It answers all those questions.
And why does the polymorphic?
Yeah, I'm pretty interested in that kind of stuff.
Well, I just want to hear.
Why does the coding principles you're talking about explain why they have to be in specific locations?
That's my point. When you learn how
the
design works,
you
you learn how to use it for yourself.
You serious?
How God used it.
Well, let me ask a basic question that everybody would understand. Okay.
Yeah, I'm trying to help. I'm trying to be serious.
Andrew, no, and you're doing great, Joe.
Are you going to analogies
Why
again?
is the engine in
Please don't go
all
to
sorts of
analogies.
modes?
It's
No,
called
stop it,
software
Andrew.
engineering.
Stop
It's
it.
not useful to the argument.
Why?
Oh,
You're
Answer
playing
this
dumb,
question.
dude.
Why is the engine found in all sorts of modes of transportation in the same spot?
because it's
I'm
a
not
good
going to
design.
answer it until you answer my
Exactly.
original
You don't want to
question.
answer it because it destroys your
Well,
objection. The engine
so
is designed
And
in
cars
similar
are
spots
not
and modes of
applicable to
transportation
genetic
for
sequences.
functional purposes, for good
Well,
design. It's
design
common
is.
design.
Yes,
It's
they
an
are.
analogy, and analogies are not applicable here.
No, it isn't. It is in the realm of design. So whether it's software or any body of work, we call it any engineering body of work, it's a combination of tried and true design principles that we share across industries. And so that's what Donnie is trying to help, I think, illustrate through. There's common design principles that we
Amen.
can learn from and adapt. But more importantly, to answer your specific question and questions, that everybody likes to ask about, to learn how and to learn the answers to why God did certain things in the language of God, as the Human Genome Project calls DNA. Learn how to code yourself. Then the answers become clear.
Right. And here's the thing. The evolutionists, they argue from their own, it's a straw man. Okay. So they don't want to first assume our position, steel man our model. They just want to say, no,
I am
don't
assuming
go to
your
car
position.
analogies. Our model suggests, okay, that what we're looking at is due to common design. And if we're made in the image of God, as the Bible suggests, we would predict that we should be able to get a sense for how God designed the biological world,
Which
based on the
fails
way
for
we
multiple
design
other
things.
reasons, which I can
No,
explain.
it doesn't fail. The only person failing, okay, it's not your fault. The only person failing is the PhD evolutionists like Dan, who use these weak arguments, and then you repeat
Why
them. It's
are
even
you
your
not
fault, it's
addressing
Dan's
the
fault.
original topic?
I've got my screen
Let
share.
me say it again.
I'm
Let me
almost done.
say
I'm
it
almost
again.
done. I got my, okay, go ahead. Say it again, but, and I want the audience to recognize the fact that you're dodging the functional question, just like all evolutionists, speed of sound, everybody. You
Well,
guys
I'm not
never
dodging the
answer the
functional
simple question.
because
How
I'm
can
saying
these
even
functional
if
roles
they
evolve?
do have a function, that doesn't explain why they have shared locations. Not just
Yes,
the fact
it
that we
does.
share them
Oh my
between
God.
organisms,
It's like talking
but
in
the fact that
circles
they are
now.
the same locations in the genome. You
It's the way
claim
the
to have
designer
explained
put it
that, but you haven't.
Okay, guys, hey, just let Andrew take as much time as he wants.
Hey,
Then I
hey,
want
I'm done.
uninterrupted
Andrew.
time to make my point.
Andrew, let me make a quick point. Andrew, why do you think chimpanzees and humans have nails in the same place? Why do you think that might be? Moron, dude.
Well,
Okay,
to be
if you
nice
just look
about
at
it,
this basic slide, no, and I understand that Andrew doesn't like this, and that's fine because a lot of evolutionists are willingly ignorant. This for the audience, because this is for the audience. There's a lot of evolutionists they're just not willing to change their mind. Andrew is pretty
Your
much
nail
asking,
argument
Andrew,
there is
please
not
don't talk
applicable
over me.
to
I'm almost
specific
done.
genetic elements, and I explained why earlier.
Okay, listen. Andrew's question is pretty much, if my shared his screen, John, why does this, crossover vehicle and these sedans and this SUV and so on and so forth, how come the tires are all, designed in the same spot? How come the windshields are all in the front? How come the
This
engines
is
are all
irrelevant because
here?
I already
No, it's not
showed.
irrelevant. That's your question. Human engineers are designing these functional parts in the same spots for a reason and good reason. Now, if we have an ERV sequence that functions in embryological development, then it makes sense. Notice here, what do we share most with in the biological world? Well, when it comes to anatomy, morphology, genetics, and physiology, we share the most with the chimpanzee. So yeah,
That
we are
doesn't
going
mean
to
we should
expect.
share molecular sequences.
Of course it does.
Yes,
No,
it does.
doesn't.
It does.
Yes, it does.
Do you not know what the wobble
You're
base
not
is?
debating in an honest way, Andrew, okay? Because anybody who's objective should be able to recognize the fact that humans, chimpanzees, look we've got both binocular vision, we're mammals, we have hands, feet, we're built the same. Therefore, the underlying genetics, that codes for the phenotype and the physical features are obviously going to be similar as well.
The genetic code is redundant. That doesn't follow.
Just like my code is, Andrew. My code is redundant. My code has mistakes. My code has all kinds of comments and things
that the
years
molecular
past
sequence
that I never knew was
doesn't
going to
have
stick
to
around.
correlate
I
with
like to
the
finish my point.
morphology.
I want to finish my point. I know you don't like to hear this, but the things that what I describe as anti-scientists make believe about reasons why DNA can't be coded for or can't be engineered, the same exact things happen with engineers like us. So it's not just objectivity, I would argue, Donnie. It's raw experience. A lot of people don't have experience in science or engineering or technology in general. They're just clueless. They're like, often, not to be too facetious, but it's like a kindergartner trying to explain to a plasma engineer their crayon is a good dopant material, for plasma physics. It's like, okay, well, do you want to learn how plasma physics works first before you ask questions on how and why things are? It's the same thing with these biology and information debates, I think.
Oh, again,
but the thing is, crayons don't reproduce, Joel.
Okay.
Yeah,
I mean, this is the level of sophistication we get from the evolutionists. Andrew, please just answer the basic.
Donnie, maybe crayons could reproduce if given enough time.
I think people just lazy nowadays. They don't want to do the research.
Yeah. I mean, I'm sure human engineers, I'm sure, car manufacturers, car companies would love if cars could reproduce. I mean, that would help with labor. That would help with time. I mean, you design one car and then you just hit a button and they just keep reproducing.
Answer my arguments, then I see no reason why I should stay here.
No, Andrew, you're dodging. Okay, now I'm actually starting to get a little bit annoyed. Answer the basic question that I asked you when you first joined. Show me one single technical paper. I don't want, I think this, I think that, maybe this, maybe that, imagination, story time. Show me one empirical example of a non-functional ERV or non-functional property of an ERV going from non-functional to functional or even altering their function. Everybody be quiet. I want to hear Andrew's answer. Go ahead, Andrew.
Why should we expect that to happen in a single generation?
Exactly. So you don't have an example.
That's all! He's down! And it is all over!
Well, nobody has an example. No evolutionist has an example. It's why they dodge the function and say it's irrelevant because it destroys the position.
Don't you agree with Dr. Dan's example of the koala? Dr. Dan made the example of the koala, KORV.
And just to clarify real quick, Andrew, that comment you made, that's faith-based. In science, we try to confirm through observation.
Do you know Dr. Dan's koala argument?
Yeah, the KORV.
Does he know about it?
Andrew?
Well, you've been asking me a lot of questions, so how about I ask you one?
Well, I mean, I think I've asked one. Okay, yeah, go ahead.
All right, so are you going to deny the fact that you can have genes on different chromosomes and still perform the same function?
That's classic polymorphism. That's exactly what I was trying to describe earlier tonight.
Right. So there is no functional necessity for these two genes to be on the same exact homologous sites on the chromosomes between these two different species. Because you see that with other genes. You see it with
how do you know that these different genes that are identical aren't used for the same function? How do you know that? Because
they perform the same function.
Then isn't that
like hemoglobin, for example? You find it in the mouse genome. It's on a different chromosome compared to the human genome.
Well, of course.
It doesn't matter where it is in the genome.
Well, here's the thing: the human and the mouse are a lot different than a human and a chimpanzee.
If I copy and paste
the same argument applies.
Identical code from one program into another, I do that so it does the same thing. Well, I don't understand why you ask these questions.
Well,
Andrew,
with the ERVs, we find them in the same locations.
Yeah,
explain
but
that
not all
from a functional standpoint.
We have human-specific ERVs. For example, a few of the papers I was showing was
the shared locations of these ERVs between the species.
Right, but we also have chimpanzee-specific ERVs.
Right, and that's irrelevant
ERVs.
because you can't have ERVs sequences unique to a lineage.
In a scientific way, it's very, very simple. So my polymorphic code design, my class functions that I write in my code today, and everybody else that does this stuff, is in different sections of my code. I've got, whether I'm doing PHP or C+ or original C, whatever I'm using that has OOP type technology or whatever you call it, functionality, fundamental code design is the same. I'll have similar structures and identical structures in different parts of my larger code, or even sometimes in identical places. It just depends on however I decide to choose to design and
Right.
I'll make
So
it
you're
work. and I'll test
saying
to
you
make sure it
don't
works.
make testable predictions about where they should
Yes,
be
I do.
specifically.
That's all we do. This is crazy. This is like,
Well, you said
it's
it's
like, how
it's
do
up
you
to
know how
the
to
whim
code?
of the
By
designer,
doing
basically.
it, huh?
Andrew, you realize that if any more of the
Crazy.
genome
I'm trying.
is
I'm trying to help on
if the
a
genome
real,
is any more than
real
just in
level.
general, especially for the audience, I just want to make this understandable. If any more of the genome is functional than, let's say, 15-20%, evolution can't happen.
Why are you keep
Evolution
going
cannot be true.
address
Evolution
my specific
requires
point?
junk. But we have
And
evidence that over 80% of the genome is functional. That means all the sequence similarity you're talking about, the nested hierarchical distribution of these DNA sequences, it's hierarchies by design and not descent. You require junk. You require the fact that these genetic sequences reflect descent with modification. That's not what we see. That's a
Okay,
falsification.
let me
of
put it this way.
descent with
Are you
modification.
aware of the fact that, say, for morphology, you have these nested hierarchical patterns that don't follow function, that don't follow the specific environment? They aren't there by functional necessity at all.
my understanding to that, Andrew, is that all DNA is functional. It's
Well,
been that little myth.
not just talking about
There's a
DNA
way
here
to
for a
called
second, just
active
talking
versus
about
inactive.
morphology to illustrate the point.
Well, the modern conversations that I have in these fields with other people is that we have active versus inactive genes. It's all functional. As a matter of fact, the liver function cells, the DNA in our livers and our brain cells, they're literal data archive type systems in those DNA, in those adaptations for the cells in those groups and those organs, they'll change. So I love how it's described. The chromosomes in the liver cells, they'll literally unwind. They'll change shape, and so all the once falsely assumed, inactive or non-functioning genes, whatever. There's literal scaffolding. There's code that's because the DNA it's not only quaternary. It's not only 4-digit. It's also 3-dimensional. The shape and where the chromosomes, where the different structures touch and meet, affects the translation. So it's a freaking mind-boggling miracle. But the shape is codified in the structure, in the things that don't seem to have direct translation, but the scaffolding still is required, is absolutely 100% necessary for the translations to work. Without it, it wouldn't work. And then the other cool thing about it is that just like in human software technology, we have, I don't know if anybody, you have a hard drive, right? So you've got data that you store that doesn't do anything. It's inactive. It sits there until you need to read and access it, right? And so DNA does the same exact thing. There are protein structures, there's enzymes that liver cells have archived, literal archive technology that the liver cell doesn't normally transcribe those parts of the DNA to make these certain types of proteins, whatever. But when it detects, there's auto detection routines built into this. When it detects certain poisons or things that are not healthy for your body, your liver cells react to it and change shape and unfold in different pre-programmed ways, so it can read the stored data that's normally physically buried in these 3-dimensional structures, so it can read the necessary information to attack these pre-programmed self-identified poisons to try to help keep you healthy. It's mind-bogglingly it's code. It's pure raw software, man, in so many different levels.
And one thing I'd like to add too is the fact that during development, during these various windows and stages of development, we have a lot of these genetic sequences, okay, including non-coding RNA genes like pseudogenes, but specifically the ERV sequences that we're talking about here that are only functional under these certain conditions. So when the developmental process is complete, then many of these necessary ERV sequences are turned off. They're no longer active, or they're repurposed, right? So they do a job in development, then they're turned off and repurposed to be turned back on maybe at some point in the organism's life via environment, epigenetic or something.
Yeah.
So the evolutionists are very much wrong when they try and say certain sequences or the vast majority of ERVs are non-functional. Even if they were to do a knockout experiment, knock it out and say, look, the organism's fine. Yeah, it's because that DNA element's not expressed. It's no longer active. So the evolutionist is premature to conclude that the majority of these sequences are junk. Go ahead. I just wanted to point that out.
Can you see my cursor?
That's even more further kind of confirmed or proven through Hox genes. I'm sure you're familiar with, Donny, and homeobox genes. That's exactly what they do. They're primarily, if not exclusively, in most organisms used for fetal development. Once the fetus is formed and the organism's the basic function of and the foundation of the structures of an organism are created, then the Hox genes turn off.
Exactly. Yeah, you nailed it. It's science fiction on the molecular level.
Well, it's literal technology. Literal. It's not figurative. It's not making a comparison like you were making your analogies, like you were saying, Andrew. It's literal advanced technology. Our most, and I've been doing this stuff for many decades. The bleeding edge advanced technology that we develop for things that I would love to talk about as well. We are caveman technology based. We're still working with bare clubs, and I don't think we've even discovered fire yet compared to God's technology that we're talking about here. We have to learn things on our own level to be able to codify and do things for our own technological needs, just to be able to learn the things like Antangelo and I talk about often. We're only barely beginning to understand things about God's DNA codes technology because of our advanced technology. The more our technology advances, the more we learn things that God already used in his designs. It's that crazy.
Can you see my cursor?
Yes, sir. But can you, right. I mean, I'd like to get some acknowledgement of that. I mean, is there any conversation with that?
What about
the evolutionists can't rebut it. It's just irrelevant.
Well, can we at least talk about it?
It's so bad for evolution. It's such a bad time to be an evolutionist. Let's hear Andrew's point here. Okay, yes, we can see your cursor. Chromosome 5. Okay, so what's up with it? Go ahead.
All right, so I'm just using this. I don't know specifically what chromosome 5 does or anything, but I'm just using this as an example just to demonstrate my point, okay? So since you can see my cursor, so this G region right here on the chromosome, let's say this is where an ERV inserted itself. Just from going from the standard way of looking at it, I guess. So assuming that an ERV inserted itself right here, we find an ERV right here. We find it in a different position, say on a different chromosome, a different organism, and it would still perform the same function. But instead, we find it right here.
In modern code, Andrew, it's called a base class. It's a section of code that's used in other parts of the program.
Okay, can you explain how that's relevant to this specifically?
Because that's exactly what that's doing. And again, jumping genes further give examples of what you're trying to allude to. The idea that there is common code in multiple sections used for similar and even sometimes different functions or feature groups or whatever you call it. That's how modern code is.
Right, but the point I'm making is it doesn't need to be in the same position though.
Why not?
Because you can have genes that are at different positions on, say, different chromosomes, and they still perform the same function.
We do in a modern code. Why can't God do it in his code? We literally, again, I tried to explain it the most simplistically way I could. I don't know how to break it down further. My code today, I have identical functioning code. I have ERVs literally in my code that I designed, that I wrote on purpose to avoid having to copy and paste stuff that do identical things. I do that for a reason, just like the DNA code does, exactly for the same reasons the DNA code does.
But let me add something too, because I do. But here, a lot of what we're saying
they share them for a common purpose, but why do they exist at the same
site? New object as we talk about it in human language.
Right, but why do they share them at the exact same site on the chromosome?
Well, that's because that's the way the guy that wrote the code did it, just like me. I'm trying to explain.
He did it that way because that's how he did it?
Yes.
It doesn't explain anything.
No, dude, when you learn to write your own code, it's going to be written the way you thought of was best way to do it.
So
And
again, you're
sometimes
saying it's
there's a
up to
better
the
way.
designer's whim, basically. There's
The-
no explanation why you put it there for any functional necessity.
Well, no, again, okay, that goes back to what I wanted to talk about much earlier tonight. We can reverse engineer these sequences, these code, these algorithms. We can, and we do. That's what Donnie was trying to talk about. We understand. The only way you can even you yourself can pretend to hope to understand what sequence is functional or not is that we've reverse engineered what the function was. We followed the code trail, what the translation did, where it translated into RNA, where the tRNA, the what do you call it? Help me, Donnie. The key in the ribosome. Yeah, the T in RNA, in the messenger RNA meet. We follow all that now. That's how the COVID vaccine was developed. So we can literally watch God's programming and his compilers work in real time and learn how these functions work. And we can backtrace, okay, this messenger strand was we have all kinds of really cool tools that can watch where that piece of code snippet came out of the nucleosome directly off the source code, which is DNA, and what it does. It makes this protein. Why does it need to make this protein from this amino acid group? Why does it need to do that? Well, it makes this chemical. Well, why does it need to make this chemical? Well, it creates this spike protein or this whatever, to do whatever that happens in
And
life.
also, and one important point to know,
Well, that's
is a lot of
explaining why it
am I
has
going to
that
get over
particular
talk every
function.
time? I want to make a simple point. A lot of these DNA elements, okay, are actually multifunctional.
Yes.
So where you keep asking the question, Andrew, we've got this one function and we share it in the exact same spot, or we don't share it. Like the mice, the genome you're talking about is in a different spot than in humans when we should expect it to be in the same spot, more or less. Given the fact that a lot of these sequences are multifunctional, as in, they function in information flow, but also in cell optimization, which is going to differ depending on the creature. So let's say, given the multifunctional nature of a lot of these genetic sequences, then we may expect more of them to be in the exact same spots within humans and chimps, but yet different spots between humans and let's say a mouse, because information flow in a human and a chimpanzee could be very similar, but very different with the mouse. So the mouse will have the DNA element in a different location, even though maybe its main function is embryological development. Go ahead.
That doesn't make any sense, though, because the specific function of a genetic sequence, again, doesn't depend on its specific location. This is basic genetics.
No, it does. Not only does it matter in terms of translation, but like I was talking about earlier.
Okay, can you give an example?
Well, yeah, if you want to go into ENCODE or something and look at examples, we could, but I mean, that's getting into some serious minutia. But the other point I was just trying to make was
I'd like to hear a specific example here, because it seems like you're making some generalizations.
My understanding is that all sequencing is the positions of it, not just in the two-dimensional, the linear form within the code line structures, but again, the third-dimensional shape. If the chromosomes don't bend and twist and whatever and touch in exact right spots, oftentimes that the code will fail as well. There's an extreme amount of orchestrated design, and to be able to make this function.
We're talking about recombination there, right?
No, just basic function code DNA function.
Wait, you're talking about the chromosomes bending and twisting and whatnot. I don't know what you're referring to there.
Well, look it up. That's what I'm saying. The stuff that Christians primarily are discovering today has invalidated what Christians thought of 100 years ago that atheists and others are still trying to pretend to understand. The stuff that we're doing today, it's out there. I mean, Donnie tries to touch on it, and Tangelo, I mean, John, everybody that does these YouTube things.
So I just got back. Andrew, please don't tell me that you are still are you playing dumb on inter and intra chromosomal gene regulation?
Yes.
That's not what I'm talking about here.
Well, I'm pretty sure that's why I just heard Joel describing. I'm pretty sure that's why I just heard Joel describing in relation to you're twisting and bending and such of chromosomes and having to touch in a
well, right. He brought that up. That wasn't what I was originally referring to, though.
Right, but I'm pretty sure I heard you deny that was happening.
He doesn't know. He didn't know what happened. He said.
I was clarifying what he meant by that specifically. I wasn't saying none of that actually happened.
Okay, well, I came on the tail end of this. What I heard was him talking about the specific location of gene sequences having relevance from a coding perspective, and then you said it didn't, and then he said no, it does, because you have to have it in line both from a linear perspective as well as have the shape and the three-dimensional folding.
Well, I'm saying it doesn't matter from a coding perspective, because we see it with genes that in the lab today. The specific function of a gene doesn't depend on its specific location on a chromosome or the entire genome.
Yes,
It'll
it does.
still
That's how
perform the same
translation
function.
works.
Well, okay. So you're saying that you're talking about the specific sequence for that ultimately results in a protein. Is that what you're saying?
Yeah, just a gene in general. Yeah.
Right. So
Translation.
the point that Joel's making is that yes, you can have that, but you have to have the other regulatory coding functions in order for that outcome to happen. So in relation to from a coding standpoint, right? Yeah, you can have all of this other surrounding necessities before you get to the lines of code that result in something you see on your screen.
Right. You're called the regulation upstream, basically.
Right, but I'm talking from a general coding perspective as well, right? There's all sorts of stuff that is going on that is not, versus the lines of code that result in the freaking form fields or whatever you're seeing on your computer screen, like on a website or whatever, right? There's ridiculous amounts of code that is not what is the result. Ultimately, it's resulting in what you're seeing, right? But the visual representation, the HTML and CSS, whatnot, the calls are having for that are just a minuscule fraction of it, and the end outcome. And there's always additional components for function that are necessary to be in specific order. Otherwise, you don't get that output. And that exact same logic applies in biological systems and genetics. And this is why, Andrew, I know I bash you over the head of this over and over again, but like, this is why you need to go and learn what we're talking about and the significance of this, because if you do, number one, you'll understand biology way more if you actually go and take the time to comprehend these points.
Answer the basic question that I asked you when you first joined. Show me one single technical paper. I don't want, I think this, I think that, maybe this, maybe that, imagination, story time. Show me one empirical example of a non-functional ERV or non-functional property of an ERV going from non-functional to functional, or even altering their function. Everybody be quiet. I want to hear Andrew's answer. Go ahead, Andrew.
Why should we expect that to happen in a single generation?
Exactly. So you don't have an example.